Here we have a SAT math question. Okay, let's go with the information. If A and B are positive integers and A square into B square equals to 24, which of the following could be the smallest value of A? Okay, the first information says the A and B are positive integers, and so here the value of the expression A square into B square equals to 24, and we have to find the smallest value of A. Okay, now let me take the given equation, that is A square into B square equals to 24. Okay, now let's consider an algebraic identity, that is difference of two squares, A square into B square. So whenever we have difference of two squares in the form A square into B square, it can be written in the factored form, that is A positive B times A negative B. So here in our problem, the given equation, we find this expression, the difference of two squares over here, exactly A square into B square. So the factored form of this A square into B square is A positive B times A negative B. So we can write this expression on the left side in factored form. Then I'm getting A positive B times A negative B equals to 24. So here the product of two quantities equals to 24. Okay, now let me write the possible pairs of factors for this 24. Let me write 24 over here. So since we have a product of two quantities equals 24, I'm going to find all pairs of factors for 24. Let me start with 1. So 1 times 24 is 24, and I can take 2. 2 is a factor of 24. 2 times 12 is 24, and if I take 3, I'll be getting 8. 3 times 8 is 24. And now I can take 4. 4 times 6 is 24. I cannot consider 5 over here because 5 is not a factor of 24. 6 will work. 6 times 4 is 24. And 7 will not work. And if I take 8 over here, it will be 3 times 3 is 24. 9 will not work. 10 will not work. 11 will not work. And 12 works. So 12 works. 12 times 2 is 24. And 24 times 1 is 24. Okay, now I assume these are the values of A positive B. Let me write over here. And these are all the values of A negative B. Okay, here the question says A and B, both of them are positive integers. Since both A and B are positive integers, the sum of two positive integers is always greater than the difference of two same positive integers, that is A negative B. That is A positive B has to be always has to be greater than A negative B, because both A and B are positive integers. So here the values we have over here have to be greater than these values, because the values we have over here are the values of A positive B, and so here we have values for A negative B. So in the first column, the values over here have to be greater than the values in the second column over here. Okay, now let me consider the first pair. If I consider the first pair, the value of A positive B is 1, the value of A negative B is 24. So as I said earlier, A positive B always has to be greater than A negative B, since A and B are positive integers. But here the value of A positive B 1 is less than the value of A negative B, so we can reject the first pair. For the same reason, we can reject the second pair as well, the third one as well, and fourth one as well, because in all these four pairs, the values of A positive B are greater than the values, the values of A positive B are less than the values of A negative B. Okay, now what we can do is we can go to the fourth pair of factors. Here the value of A positive B is 6, the value of A negative B is 4. So the value of A positive B, the 6 is greater than 4. So we can consider this particular pair of factors. So that is 6, 4. So that is we can take A positive B equals to 6, and the value of A negative B is 4. Let me write it over here. Okay, now let's solve for A in the system of equation. If I add the equations, positive B, negative B will cancel out. A positive B will become 2A. On the right side, 6 positive 4, I'm getting 10. Let's divide both sides by 2. When I divide both sides by 2, this 2 will cancel out. I'm getting A equals to 5. Anyways, I'm getting a positive integer for A. This one satisfies the condition what we have here. So A equals to 5, and also we find this value 5 in option B. I think the smallest possible value of A may be 5, but not sure about that. So we have to check with the remaining factors. Anyways, we have verified this particular pair of factors, and it satisfies the condition what we have in the question, because when I consider the 6 as a value of A positive B, 4 as a value of A negative B, I'm getting A equals to 5, which is a positive integer. Okay, now let me check this particular pair of factors. That is A positive B is 8 and A negative B is 3. Let me write it over here. A positive B is equal to 8 and A negative B equals to 3. Okay, now let's solve for A in this equation. Positive B, negative B will cancel. 2A equals to 8 positive 3 is 11. When I divide both sides by 2, I'm getting A equals to 5.5. Even though it is a positive value, it is not an integer, because according to the question, A has to be a positive integer. So when I consider the pair of factors 8 and 3 for A positive and A negative B, I don't get an integer value for A. So we can reject this particular pair of factors. Okay, now let me consider this pair of factors are 12 and 2. That is a positive b equals to 12 and a negative b equals to 2. So now let's solve this one. Positive negative b will cancel. I'm getting 2a equals to, here when I combine 12 and 2, I'm getting 14. Now I divide both sides by 2. When I do so, I'm getting a equals to 7. Okay, here I'm getting a positive integer 7. So it satisfies the condition we have over here, that is a is a positive integer, but the question targets the smallest value of a. So already we got a value for a using the pair of factors 6 and 4. I got a equals to 5. So even though I'm getting a positive integer for a over here with the factors are 12 and 2, so this 7 is greater than the value which already got it. So our aim is to get the smallest value of a. Since this 7 is greater than the first value we got for a, we can reject this one also. Like let me erase the work what I've done over here. So we can reject this pair also. Now finally we can try with 24 and 1. So there is a positive b equals to 24 and a negative b equals to 1. So when I add them, positive negative b will cancel out. I'm getting 2a equals to 25. So when I divide both sides by 2, I'm getting a equals to 12.5. Even though I'm getting a positive value for a, this 12.5 is not an integer. So we can reject the last pair of factors also. So only from this pair 6, 4, that is when a equals to a positive is 6 and a negative b is 4, I am getting the smallest value of a, that is 5. We find the smallest value of a, that is 5 in option B. The correct answer choice for this question is option B.